Welcome to Advanced Cloud Armor. Welcome to our comprehensive journey into Google Cloud Platform's Cloud Armor, the enterprise-grade web application firewall and DDoS protection service that has revolutionized how we protect modern applications. Today, we're going to dive deep into the advanced features that make Cloud Armor a cornerstone of enterprise security architecture. I've personally implemented Cloud Armor for Fortune 500 companies, and I can tell you that what we'll cover today represents the cutting edge of cloud security. We'll explore not just the basic concepts, but the advanced threat intelligence integration, adaptive protection mechanisms, sophisticated rate limiting strategies, and comprehensive bot management that enterprises rely on to protect billions of dollars worth of digital assets. This isn't your typical overview presentation. We're going hands-on with real G-Cloud commands, enterprise deployment patterns, and battle-tested configurations that you can implement immediately in your organization. Let's begin this exciting journey into advanced Cloud Armor security. Cloud Armor Architecture Deep Dive. Let's start by understanding the sophisticated architecture that makes Cloud Armor so powerful. This isn't just a simple firewall, it's a distributed security platform that operates at Google's edge locations worldwide. What you're seeing here is how traffic flows through Google's global infrastructure. When a request hits your application, it doesn't go directly to your servers. Instead, it first encounters Cloud Armor at one of Google's over 100 edge locations worldwide. The magic happens at the edge. Cloud Armor evaluates every request against your security policies using Google's custom hardware and machine learning algorithms. This means threats are stopped before they consume your bandwidth or compute resources. Notice how the architecture separates different types of protection. We have Layer 3/4 protection for volumetric attacks, Layer 7 protection for application attacks, and the adaptive protection system that uses machine learning to identify new threat patterns. The key insight here is that Cloud Armor isn't just reactive, it's predictive. It learns from attack patterns across Google's entire network and applies that intelligence to protect your specific applications. Let's break down the core components that make Cloud Armor such a comprehensive security solution. Understanding these components is crucial, as each serves a specific purpose in your overall security strategy. First, we have security policies. These are the containers for all your security rules. Think of them as the blueprints that define how traffic should be handled. Each policy can contain up to 100 rules, and you can have multiple policies for different applications or environments. WHAF rules are where the real magic happens. These include both pre-configured rules based on OWASP Top 10 and custom rules that you create using common expression language. The pre-configured rules are constantly updated by Google's security team based on emerging threats. Rate limiting goes beyond simple request counting. You can implement sophisticated throttling based on IP addresses, user sessions, geographic regions, or custom request attributes. This is essential for preventing both brute force attacks and resource exhaustion. Bot management uses behavioral analysis and JavaScript challenges to distinguish between legitimate users and malicious automation. This is becoming increasingly important as bots now make up over 40% of all web traffic. Geographic controls allow you to implement location-based access policies, which is crucial for compliance requirements and threat landscape management. Security policy types comparison. Understanding the different types of security policies is fundamental to implementing Cloud Armor effectively. Each policy type serves specific use cases and has different capabilities. Cloud Armor policies are the most common and powerful. These provide full Layer 7 protection and integrate with global HTTP/HTTPS load balancers. They support all the advanced features we'll discuss today: WAF rules, rate limiting, bot management, and threat intelligence. Cloud Armor Edge policies are designed for CDN protection and operate even closer to users. These are perfect for protecting cached content and can handle massive traffic volumes with minimal latency impact. Network edge policies focus on layer 3/4 protection and are ideal for protecting TCP/UDP services. While they don't have the sophisticated application layer features, they're extremely efficient for network-level threats. The key decision factor is understanding your application architecture. If you're serving HTTP traffic through global load balancers, CloudArmor policies are your best choice. For CDN-heavy workloads, consider edge policies. For network services or mixed protocols, network edge policies might be appropriate. Many enterprises use a combination approach: CloudArmor policies for web applications, edge policies for content delivery, and network edge policies for backend services. Traffic flow fundamentals. Understanding traffic flow is crucial for optimizing both security and performance. Let me walk you through exactly how a request travels through Google's infrastructure when CloudArmor is enabled. When a user makes a request, it first hits Google's Anycast IP address. This automatically routes the request to the nearest edge location. This could be one of over 100 locations worldwide. The beauty of this approach is that attacks are absorbed at the edge, not at your origin servers. At the edge, CloudArmor immediately begins evaluating the request. First, it checks IP reputation using Google's Global Threat Intelligence. Then it applies your custom security policies in priority order. This entire process happens in microseconds. If the request passes security checks, it's forwarded to the global load balancer, which then routes it to healthy backend instances. If it's blocked, the user receives an immediate response without any load on your infrastructure. What's particularly powerful is the feedback loop. CloudArmor continuously learns from traffic patterns and updates its threat models. It can also share threat intelligence across different policies and even different organizations, creating a collective defense mechanism. This architecture means you get both security and performance benefits. Clean traffic is accelerated through Google's network, while malicious traffic is stopped at the edge. Setting up your first security policy. Now let's get hands-on with creating our first security policy. I'll walk you through each command step by step, explaining not just what we're doing, but why we're doing it and what options are available. The first command sets up our environment variables. This is a best practice that makes our commands more maintainable and reduces the chance of errors. Notice that we're using a descriptive policy name that includes the environment. This is crucial for managing multiple environments. Setting the project ensures all our commands operate in the correct context. The Enable Services command activates the Compute Engine API, which is required for CloudArmor operations. This step is often forgotten but absolutely essential. The Security Policy Creation command includes several important flags. The description should be detailed because you'll thank yourself later when managing multiple policies. The type CloudArmor specifies we want full Layer 7 protection capabilities. Log level verbose is crucial during initial setup because it gives you detailed information about rule evaluations. You can reduce this to normal later for production environments to reduce log volume. The verification command at the end confirms our policy was created successfully and shows us the basic configuration. Always verify your commands. It saves hours of debugging later. WAF Rules Implementation Deep Dive. Now we are getting into the meat of CloudArmor, implementing web application firewall rules. This is where you transform a basic load balancer into a sophisticated security platform capable of stopping the most common web application attacks. Let us start with SQL injection protection. The first command creates a rule using Google's pre-configured expressions. The SQLi stable expression is based on the OWASP core rule set and is continuously updated by Google's security team. Priority 1000 gives this rule high importance but leaves room for higher priority allow lists. The deny 403 action is important. It immediately blocks the request and returns a 403 forbidden status. This is better than deny 404 because it clearly indicates the request was intentionally blocked, which helps with debugging legitimate issues. For XSS protection, we use XSS stable with priority 2000. Notice how we are incrementing priorities by 1000. This gives us room to insert additional rules later without renumbering everything. Remote file inclusion attacks are particularly dangerous because they can lead to complete server compromise. The RFI stable expression catches attempts to include remote files through URL parameters. The final command shows how to create custom rules using CEL expressions. This particular rule blocks common attack tools by looking at the user agent header. The regex pattern matches multiple attack tools in a single rule, which is more efficient than separate rules. Advanced Expression Language, Common Expression Language, or CEL, is where CloudArmor really shines. It allows you to create incredibly sophisticated rules that can examine any part of an HTTP request and make complex decisions. Let's break down this complex expression step by step. The first part checks if the request path starts with /admin. This identifies administrative interfaces that need extra protection. The InIP range function is powerful. It checks if the source IP is within our trusted corporate network range. The logical and combines these conditions, so the rule only triggers for admin access from untrusted IPs. The geographic restriction example shows how to combine multiple conditions with OR operators. This is much more efficient than creating separate rules for each country. Time-based rules are incredibly useful for maintenance windows or business hours restrictions. The hour function extracts the hour from the current time, and you can combine this with time zone considerations for global applications. Header inspection is crucial for detecting automated tools and bots. User agents can be spoofed, but many attack tools use default headers that are easy to identify. The request size limit prevents resource exhaustion attacks. Notice how we can check different parts of the request: body size, URI length, header count, and take appropriate action. These examples show just a fraction of what's possible with CEL. The key is understanding your application's normal behavior and creating rules that allow legitimate traffic while blocking attacks. Rule priority and evaluation order. Understanding rule priority is absolutely critical for CloudArmor success. Rules are evaluated in ascending priority order, and the first matching rule determines the action. This means rule ordering can make or break your security policy. Looking at our priority structure, you can see a clear hierarchy. Priorities 100 through 999 are reserved for allow list rules. These should always come first because you want to ensure legitimate traffic is never accidentally blocked by security rules. The corporate IP allow list at priority 500 ensures that traffic from your offices is never blocked, regardless of what other rules might match. This is your safety net against accidentally locking yourself out. Threat intelligence rules at priorities 1000 through 1999 come next because they represent high-confidence threats that should be blocked immediately. These use Google's global threat feeds and are automatically updated. WAF rules occupy priorities 2000 through 4999. We start with the most critical attacks like SQL injection, then move to XSS, then other attack types. This ensures that the most dangerous threats are caught first. Rate limiting rules at priorities 5000 through 5999 are placed after WAF rules because you want to block attacks before they consume rate limiting resources. Geographic restrictions are at priorities 6000 through 6999 because they are broad strokes that shouldn't override more specific security rules. The default rule at the maximum integer value priority acts as a catch-all. In this case, it allows everything that hasn't matched previous rules, but you might choose to deny by default for high security environments. Preview mode and testing strategy. Before we deploy any security rules to production, we absolutely must test them thoroughly. CloudArmor's preview mode is your best friend here. It lets you see what would happen without actually blocking traffic. The preview mode workflow I am showing you is battle-tested across dozens of enterprise deployments. First, we create all our rules in preview mode. This means they evaluate traffic and log their decisions, but they do not actually block anything. After running in preview mode for at least 24 hours, preferably a week. We analyze the logs to understand the impact. The log analysis command shows you exactly which rules would have triggered and how often. Pay special attention to the false positive analysis. Look for legitimate traffic that would have been blocked. This includes your own monitoring systems, partner integrations, and legitimate user behavior that might appear suspicious. The gradual enforcement strategy is crucial. We start by enabling enforcement on a single, less critical rule. Monitor for 24 hours, then enable the next rule. This approach helps you identify issues before they affect all your traffic. Rule effectiveness monitoring is ongoing. Even after rules are fully deployed, you should regularly review their performance. Rules that never trigger might indicate they are unnecessary, while rules that trigger constantly might need tuning. Never skip this testing phase. I have seen organizations accidentally block their entire user base by deploying untested rules. Multi-layer DDoS protection architecture. Now we're entering one of CloudArmor's most impressive capabilities. It's multi-layer DDoS protection. This isn't just about blocking traffic. It's about understanding the sophisticated architecture that can absorb terabit-scale attacks without breaking a sweat. Google's infrastructure processes requests, so it has massive capacity to absorb attack traffic. The key insight is that DDoS protection happens at multiple layers: network, transport, and application, each optimized for different types of attacks. At layer 3/4, Google's Edge network automatically detects and mitigates volumetric attacks like UDP floods and SYN floods. This happens without any configuration on your part. It's always on and automatic. The scale here is mind-boggling. Google has successfully mitigated attacks. Layer 7 protection is where CloudArmor policies come into play. These handle application layer attacks like HTTP floods, Slowloris attacks, and sophisticated application-specific DOS attempts. This layer requires configuration and tuning based on your application's behavior. The adaptive protection layer uses machine learning to detect attack patterns that might slip through traditional rule-based systems. It can identify zero-day DDoS techniques and automatically generate mitigation rules. What makes this architecture special is the feedback loop between layers. Insights from application layer attacks inform network layer protection, creating a continuously improving defense system. Adaptive protection configuration. Adaptive protection represents the cutting edge of DDoS mitigation. It's Google's machine learning system that learns your application's normal behavior and automatically detects and mitigates anomalies. Setting this up correctly can mean the difference between surviving a sophisticated attack and going offline. The first command enables adaptive protection on our security policy. The load threshold of 0.8 means that adaptive protection activates when your backend utilization reaches 80%. This gives the system time to react before your applications become overwhelmed. The auto-deploy load threshold of 0.9 is more aggressive. At 90% load, the system will automatically deploy mitigation rules without human intervention. This is crucial during large-scale attacks when manual response might be too slow. The confidence threshold of 0.6 determines how confident the ML system must be before auto-deploying rules. Lower values mean more aggressive protection but potentially more false positives. I typically start with 0.8 for production systems and tune down based on attack patterns. An impacted baseline threshold of 0.1 means rules are deployed when 10% of your traffic is affected. This prevents the system from overreacting to small anomalies while ensuring protection against significant attacks. An expiration second setting of 7200 means auto-generated rules expire after 2 hours unless manually confirmed. This prevents temporary mitigation rules from becoming permanent without review. The Layer 7 DDoS defense configuration enables the most sophisticated attack detection, including behavioral analysis and pattern recognition that goes beyond simple rule matching. Advanced rate limiting strategies. Rate limiting in CloudArmor goes far beyond simple request counting. We're implementing a sophisticated multi-tier strategy that can handle different types of abuse while maintaining excellent user experience for legitimate traffic. The global rate limiting rule provides overall protection against massive attacks. 10,000 requests per minute might seem high, but for a global application, this could be normal traffic. The key is the ban mechanism. Exceed 15,000 requests in a minute, and you get banned for 10 minutes. For IP rate limiting is more granular. 100 requests per minute per IP is reasonable for most web applications, but you need to consider legitimate use cases like API clients or users behind corporate NATs. The 300-second ban duration is long enough to discourage attackers but short enough that legitimate users aren't permanently affected. The path-specific rate limiting for login endpoints is crucial for preventing credential stuffing attacks. 5 requests per minute for login attempts is generous for legitimate users but severely limits automated attacks. The 1800-second ban duration for login abuse is intentionally harsh. API endpoint protection with user-based rate limiting shows the power of custom enforcement keys. By using the authorization header, we can implement per-user quotas that scale with your business model. This prevents API abuse while allowing legitimate high-volume users. Geographic rate limiting demonstrates how to implement business-driven policies. Trusted regions get higher limits, while high-risk regions face stricter controls. This approach balances security with user experience based on threat intelligence. Google Threat Intelligence Integration. Integrating Google's threat intelligence transforms CloudArmor from a reactive security tool into a proactive defense system. Google's threat intelligence is built from their global infrastructure, processing trillions of requests and analyzing attack patterns worldwide. The malware command and control feed is incredibly valuable. These are IP addresses of known command and control servers actively used by malware. Blocking these prevents infected machines in your user base from communicating with their controllers through your application. Tor exit node blocking is controversial but often necessary for high-security applications. While Tor has legitimate uses, it's also frequently used to anonymize attacks. The decision to block should be based on your threat model and user base. CVE Canary Protection is one of my favorite features. This detects active exploitation attempts for known vulnerabilities in real time. It's like having Google's security team monitoring for attacks against your specific application stack. Scanning source blocking prevents reconnaissance attacks. These IPs are known for conducting vulnerability scans and probing attacks. Blocking them reduces noise in your logs and prevents the gathering of intelligence that could be used in future attacks. Protocol attack detection catches sophisticated attacks that try to exploit weaknesses in HTTP protocol implementation. These attacks can bypass traditional WAF rules but are caught by Google's deep protocol analysis. The combined expression shows how to layer multiple threat feeds for comprehensive protection. This approach catches threats that might slip through individual feeds while minimizing the complexity of rule management, bot management and detection. Bot traffic now represents over 40% of all web traffic, and distinguishing between good bots and bad bots is crucial for modern applications. CloudArmor's bot management goes beyond simple user agent checking to implement sophisticated behavioral analysis. The reCAPTCHA integration is the foundation of bot management. By setting up the site key, we enable CloudArmor to challenge suspicious requests with interactive tests that are easy for humans but difficult for bots. This reduces false positives while maintaining security. Suspicious user agent detection catches the obvious cases. Many attack tools don't bother to disguise their user agents. But notice how we use regex patterns to catch variations and obfuscation attempts. The redirect action presents a challenge rather than immediately blocking, reducing false positives. Known malicious bot blocking is more aggressive. These are tools that have no legitimate use cases, so we block them immediately. The regex pattern can be expanded as new tools are discovered in your environment. Missing browser headers detection is based on behavioral analysis. Legitimate browsers send consistent sets of headers, while automated tools often omit standard headers like accept and accept language. This catches many scraping bots and automated attacks. Rate-based bot detection identifies automation through behavioral patterns. 30 requests in 10 seconds is clearly automated behavior. Instead of blocking immediately, we challenge with reCAPTCHA, allowing legitimate automation, like monitoring tools, to identify themselves. Cookieless API request challenges catch bots that directly access APIs without establishing proper sessions. This is common in scraping attacks and credential stuffing attempts. Edge security policies. Edge security policies represent a different approach to protection. They operate at the CDN layer, even closer to users than traditional Cloud Armor policies. This positioning offers unique advantages for content-heavy applications and global services. The key difference is where evaluation happens. Traditional Cloud Armor policies evaluate at the load balancer level, while edge policies evaluate at the CDN edge. This means cached content can be protected without ever touching your origin servers, which is crucial for handling massive traffic spikes. Creating an edge security policy requires the Cloud Armor edge type. These policies support a subset of Cloud Armor features optimized for high-speed evaluation. The focus is on IP-based rules, geographic controls, and simple pattern matching that can execute in microseconds. The geographic blocking rule for edge policies is particularly effective because it prevents malicious traffic from even accessing your cached content. This reduces bandwidth costs and improves performance for legitimate users by reducing cache pollution. Rate limiting at the edge is powerful for preventing cache abuse and origin overload. Since CDN nodes handle requests locally, rate limiting can be more granular and responsive than traditional approaches. Attachment to Cloud CDN is straightforward but requires careful consideration of cache policies. Security policies can affect cache hit ratios, so testing is crucial to ensure you're not inadvertently reducing performance. The verification commands are essential because edge policies can be harder to troubleshoot than traditional policies. The detailed output helps you understand exactly what's configured and how traffic will be processed. Load balancer integration strategies. Proper load balancer integration is where Cloud Armor policies become active protection. The integration pattern you choose affects performance, security coverage, and operational complexity, so understanding the options is crucial. Global HTTP/HTTPS load balancer integration is the most common and powerful approach. The security policy is attached at the load balancer level, meaning all traffic to all backend services gets evaluated. This provides comprehensive protection but requires careful rule design to handle diverse applications. Backend service attachment is more granular. Each backend service can have its own security policy. This is perfect for microservices architectures where different services have different security requirements. API services might need strict rate limiting, while static content services might focus on geographic controls. The verification commands are crucial because misconfigurations can be subtle. A policy might be created successfully but not attached correctly, leaving your applications unprotected. Always verify the actual attachment, not just the policy creation. Multi-region deployment requires careful coordination. Each region can have its own policies, but maintaining consistency while accommodating regional differences requires automation and careful documentation. The regional policy creation loop shows how to deploy consistent protection across multiple regions while accommodating regional variations. Notice how we use the region variable in policy names and descriptions for clear identification. Health check integration ensures that security policies don't interfere with load balancer health monitoring. Some security rules might block health check probes, which could cause healthy backends to be marked as unhealthy. Monitoring and logging deep dive. Comprehensive monitoring is what transforms Cloud Armor from a security tool into a security intelligence platform. The logging and monitoring capabilities provide insights not just into attacks, but also into your application's normal behavior patterns. Verbose logging provides detailed information about every security decision Cloud Armor makes. This includes which rules matched, what actions were taken, and detailed request information. This level of detail is crucial for tuning rules and understanding attack patterns. The BigQuery export creates a powerful analytics platform. By streaming security logs to BigQuery, you can perform complex queries to identify trends, analyze attack patterns, and optimize your security posture. This goes far beyond simple alerting to provide strategic security intelligence. Custom metrics creation enables proactive monitoring. Instead of just reacting to attacks, you can identify unusual patterns before they become problems. The metrics can feed into existing monitoring systems for integrated alerting. Real-time log analysis helps with immediate threat response. The commands shown can be automated to provide instant visibility into ongoing attacks. Understanding what's happening in real time is crucial for manual intervention decisions. Geographic attack analysis reveals threat landscape patterns. Understanding where attacks originate helps inform geographic blocking decisions and provides intelligence for threat hunting in other systems. The alert policy creation enables automated response to security events. By integrating with cloud monitoring, you can create sophisticated alerting that considers attack volume, types, and patterns rather than simple threshold-based alerts. Performance monitoring ensures that security doesn't come at the cost of user experience. Tracking latency impact and rule evaluation times helps optimize policy performance. Enterprise deployment patterns. Enterprise Cloud Armor deployment requires patterns that handle multiple environments, complex organizational structures, and stringent operational requirements. The patterns I'm showing here are battle-tested across Fortune 500 deployments. The multi-environment strategy recognizes that development, staging, and production environments have different security requirements. Development might use relaxed policies for testing, while production implements full protection. The naming convention includes environment identification for clear management. Infrastructure as code is essential for enterprise deployments. The Terraform example shows how to define security policies as code, enabling version control, peer review, and automated deployment. This approach prevents configuration drift and ensures consistency across environments. The backup and restore process is crucial for disaster recovery. Security policies are complex configurations that take time to recreate. Having automated backup processes ensures rapid recovery from accidental changes or corruption. Policy versioning enables safe changes in production environments. By maintaining multiple versions of policies, you can quickly roll back problematic changes while maintaining detailed change history for compliance and troubleshooting. The automation script demonstrates how to integrate Cloud Armor management into CI/CD pipelines. Security policy updates can be tested in lower environments before automatic promotion to production, ensuring that security changes don't break applications. Compliance reporting automation generates the documentation required for security audits and compliance frameworks. The reports can include policy effectiveness metrics, attack mitigation statistics, and configuration compliance status. Multi-region consistency ensures that security policies are coordinated across global deployments while accommodating regional requirements like data residency and local compliance obligations. Performance optimization and best practices. As we conclude this deep dive into Cloud Armor, let's focus on optimization strategies that ensure maximum security with minimal performance impact. These practices come from years of enterprise implementations and performance tuning. Rule optimization starts with understanding evaluation order. Rules are processed sequentially, so placing high-frequency matches early reduces overall processing time. Allow list rules should always come first, followed by high-confidence threat intelligence rules. Expression efficiency matters significantly at scale. Simple string comparisons are faster than regex patterns, and IP range checks are faster than complex geographic lookups. The performance testing commands help identify bottlenecks in rule evaluation. Caching strategies can dramatically improve performance. Cloud Armor caches rule evaluation results for identical requests, so structuring rules to maximize cache effectiveness reduces processing overhead. The monitoring setup provides continuous visibility into performance metrics. Latency impact should be measured regularly, especially after rule changes. Any rule that significantly impacts response times should be optimized or reconsidered. Maintenance windows are essential for rule updates and performance tuning. The automated backup process ensures that changes can be quickly reverted if they cause performance issues or operational problems. Regular policy audits identify unused or ineffective rules. Rules that never trigger might indicate they're unnecessary, while rules that trigger constantly might need refinement. The audit process helps maintain lean, effective policies. Performance baselines establish metrics for measuring the impact of security changes. Without baselines, it's impossible to understand whether security improvements come at acceptable performance costs. The optimization checklist provides a systematic approach to maintaining high-performance security policies over time, ensuring that CloudArmor continues to provide excellent protection without impacting user experience.